Okay, welcome. Wednesday, week 6, math 20. We're doing the first homework question from measurement turn-in. Okay, unit analysis. First step, write it as a fraction. So we did. And then we're trying to turn centimeters into something else.
Meters, right?
Meters. Do I write the meters on top or on bottom? Do I write the centimeters on top or on bottom?
Oh, okay. Meters would go on top, I want to say.
Yeah.
Yeah.
And I'm doing that so that the centimeters top and bottom can cancel out. So 1 meter is 100 centimeters because centi means 100th. I'm not where I want to be. I want to get all the way to yards. So I have to keep going. Oh, I should get my color scheme better too. So the numbers I should do like that. So I go back and I write another fraction. I have a meters on top. I want it to cancel. Can I go from meters to yards? Yes, it tells me up here. 1 meter is that many yards. Whoops, and again, I am forgetting my color scheme because I'm just starting this morning. Okay, so I've done the first 3 steps. Now I need to multiply. I know how to multiply fractions. I just multiply across the top and I multiply across the bottom. The only words that will be left over are yards on the top because the others have canceled, and nothing on the bottom. And that's fine. Okay, so 4844 times 1.09361. That's rounding. We turn a fraction into a plain number with top divided by bottom. We should probably round that to 53, huh? I am guessing that football fields actually are a whole number of yards. You could do this in other ways. Let's try a different thing. Holler if I'm stealing this slide from you too quickly. But instead of using unit analysis, I could do some King Henry stuff and say, first I'm going from, I don't want the comma, centimeters to meters. So start at centi, go to plain meters, and that could just be my part 1, part A. And for part B, now that I know how many meters it is, I'll change into yards. I'm going from something that is the smaller part or the bigger part. I'm going from something that contains more than 1 yard. So I will divide using the rule from the beginning of measurement with shapeshifting. No, multiply. I'm sorry. Brain is still off. So you could do it that way too, a part A and a part B of moving it from metric to metric and then doing the other conversion.
That almost seems easier for me.
Yep, different people will like different ones. As you saw, when I wasn't completely awake, then I make a mistake about whether I multiply or I divide. The reason we have unit analysis is you really can't make that mistake because the way the letters cross out and cancel, then I have to multiply or divide the proper way. But both things work. Okay, good homework question. Another homework question. Since people aren't doing percent, then let's just keep looking at the random problems for measurement. So these are the kinds of things that might appear on the test based on what we've been doing recently. Which of these should we do?
Let's do number 4 just because I like that it talks about space ninjas and space pirates and all that.
And
Okay,
it's a story problem, which always throws us off.
Yeah.
I had someone show up to office hours yesterday and she tried this and got it on her first try and was genuinely surprised, as if there was some rule that you can't get them right on your first try. So. Okay. So, Secret Villainous Moonbase has a total area of 14,000 square feet. 2 of its many rectangular rooms are claimed by the Space Ninjas and the Space Pirates, and you get the size of those rooms. What is the area of everything else? So in my picture, then we're looking for all this area here, right? Assuming I can actually color in between the lines. Where should I start?
Okay, so we're trying to figure out the area of this squiggly circle.
You're very faint, Caitlin. Can you adjust your mic and try again?
Can you hear me any better? Is that any better? Can you hear me any better?
Yes, that is better, whatever you did.
Okay, I'm trying. I'm sorry. Okay, so we're trying to find the area of the inside of that squiggly circle.
Right, the part not taken up by the colored rectangles. The rest of it where who knows which villains live there.
Is it about diameter and radius? I don't know.
Those are for circles, and we have nothing circular here.
Oh, well, it looks like a squiggly circle to me, so I just don't know.
Okay, no, not circle enough. We need real circles to talk about circumference and radius and diameter. And
Don't you have to figure out which each side is?
yeah, let's talk about the ninjas first. Why not? So how much room do the ninjas have?
Is it 45 feet by 69?
How do I take those two edges? Like, so this one is 69 and this one is 45. How do I find the whole area?
So would you take the 69 times 2 and the 45 times 2?
That would be if I
One.
want perimeter and was walking around the outside.
Oh, the
It's
inside.
45 would, for area, you would multiply the two numbers. So in this case, it would be 45 times 69.
Okay, Gildor's interrupting, but he is allowed to sometimes. Okay, length
Well,
times.
he is right. So
Okay, so back to here. Then, actually, I can go back down here. Polygon perimeter. So we want to remember the difference, and this is kind of the point of this problem. The perimeter is when you're walking around the edges, and the area is when you're trying to paint it. So use the right formula, and area length times width. So what is 45 times 69? I will multiply the
What?
3105.
3105. And we always write area in terms of square somethings. In this case, it's feet. It's square feet because that's just how we measure area. We're pretending we're putting little tile squares on the floor. How many squares that are 1 foot by 1 foot would it take to cover that? Or imagine you had some sort of defunct paint roller that you could only make one swipe at a time, and you were painting 1 square at a time. How many times would you have to do that? Okay, Pirate's turn.
3080.
Wouldn't it be the same formula? 40
is.
times 77?
It's another length times width. By the way, why do I write my L cursive?
So it doesn't look like a 1 or
So it doesn't look like a 1. Sometime in my personal math history, I wrote length times width and did 1 times the width and got my problem wrong and decided never again. So that
Or one of my
one
teachers
formula
saying
I
that
always write in cursive.
years ago too.
Okay, so we know how much space in this not to scale picture the ninjas and the pirates have. So how much is everyone else with green?
So you would just add those two areas together and then subtract them from the total, right?
Yes, so the total is the 14,000. Now we're going to have 2 different ways of doing this. Some people say, let's put these together. And then over here, we can just separate that one, subtract that one number. Whatever that is. $7,815. Other people don't like the yellow step. Some people will say, I would rather start with this, subtract one thing, and then keep going and subtract the other thing. So if you are a subtract twice person, that's great too. I'll write that kind of down at the bottom in total. So either way works. Questions about that one? No questions. Okay, should we do another random of same thing, different numbers?
Sure.
Yes, please.
Okay. How different are those numbers? 40. That's almost identical. Can we get it any more different than that? Okay, so your turn to try this. And I will do it eventually, but you try it your way first. If anyone hasn't done something on the board for that easy achievement, then write neatly and we can share your screen and you can hold it up to the webcam.
Oh,
Or if someone wants to join the Jamboard and just write directly on the screen for us, they're welcome to do that.
I'll do it on a new piece of paper because I need that one. And where's the? I'm still seeing the last one on there. Is that? Okay. So,
Oh, and Gildor, it's almost 10:30. You can stop if you want, or you can keep watching. Something I miss a lot with distance learning is I can't make food for everybody. Normally I bring in waffle makers and things like that, and we all have food because there's also culinary students in Math 20. And there was one term where one of the students had trouble with childcare. So almost every class she would bring in her kid who would then bake food for the rest of us. Hello, don't be sneaky and disruptive, Gildor. Close the door all the way, please.
okay.
Okay, I'm going to write this slightly differently and give everyone a heads up of why. Currently, we're in the mad science section, but eventually, soon, we will move on to the next topic. And when we get to measurement in the next topic, then we get sort of these puzzle problems. There's a byte taken out. What do we do? There's a triangle and a square on top of each other. What do we do? There's lots of little pieces put together. Does that make sense? We're not there yet, but we're going there. So I am going to write this thinking ahead for that kind of problem. So
Okay.
I'm going to say that the area of all the rest is the total minus the ninjas minus the pirates. And I'm starting with my big overall plan, because once we do get to those more puzzle-like geometry problems, it helps to have your plan first.
So
On the previous slide, we ended up with the plan. We're going to find the total area and subtract what's already claimed by ninjas and pirates. We didn't really need that right away, but just for the sake of establishing a good habit, I'm going to start with my big plan.
okay, so it would be 14,000 square feet for the total.
Mhm.
Minus it's 44 times 67, which would be 2948 square feet for the ninjas. and then you would multiply 39 by 76 and get 2964 square feet. And then I
Can you
added,
share your screen?
yeah, give me one sec.
You're doing it well, and I want to stop and let you do it instead of me before I
Okay.
write it my way.
Webcam is closed. There we go. Okay. Sorry, not the greatest, but you can see I did the 44 times 67. Got it there. I have horrible handwriting. I apologize. And then the 39 times 76. And I added those together, and I got 5912 square feet. And then what I did is subtracted the 14,000 from the 5,912, and I got 8,088 square feet.
Okay. Thank you very much. Okay, what I'm going to do is not quite write so much fast. I'm going to, again, assume you know how to do the problem, but show you the habits you'll want for later on. So at this point, oops, I'm still watching Craig. Do I have to stop spotlight on you? Yes, okay. So at this point, I am going to not put in, this is like my plan. Here I'm going to put in the formulas. So I'm just going to write length times width and length times width. I'm not going to rush and plug things in yet. And I'm going to plug things in only at the third step.
And is that important to do? Is that just for the example, or like?
It's just for this example.
Oh, okay, yeah, I was just
Not
making
something
sure.
I will grade you on.
Okay.
But remember when we did simple interest, sometimes we just wanted to keep track of which was the principal and which was the rate and which was the time, because it's the getting things ready where you'll mess up. Plugging things in isn't actually hard. So this is the same. If these weren't just plain rectangles, then I need to keep track of which formula goes where, and making sure that I write down each formula in the right part of the puzzle keeps me from making careless mistakes. Okay, ninjas was 44 times 67, 39 times 76. Also notice these are terms. We've talked about terms before, and we might not really have needed terms, but towards the end of the class, when we get to the next measurement section in the justice topic, then these will be a little more complicated because the formulas get more complicated than rectangles. And so the fact that these are three different terms and we can simplify them separately if we wanted to might help us. Okay, what was the answer overall? I didn't bother to write it down.
8,088 square feet.
Okay. So I've now written this three different ways because there were two things here and we saw CA do his way. So hopefully one of these four works. I don't care how you put it on your paper, but this is about all I can think of. Whatever, hopefully your brain likes one of these four ways to write things.
We do a problem with the triangles.
Are we doing? Yes, let's do a triangle problem. There is one before it though, so let's do the one before it and be working in order. This is like a tricky problem. Area is length times width, and I'm not telling you length times width, so what do we do? Oh, assuming I can actually draw a square, is that if I did go all the way around, that would be 372 feet.
And so since it's a square, it's 4 equal sides. So for this one, you could just divide 372 by 4, correct?
Correct. Everyone understand the trick?
Mhm.
Yes.
Okay, and that is
Sorry.
93. Why am I doing this? I have to make something interesting with perimeter. Asking you to add up numbers is kind of boring. So there we go. Okay, so the area of a square is length times width again. Everyone see, by the way, why we might also write this as 93 squared.
Mhm.
Yes.
That's why we call exponent of 2 squared, because it's the area of the square. Someone else want to write this out neatly and show us on their webcam and get the star for doing one on the board if they haven't yet? Should I make another one of number 5? I see a nod that I should make another one of number 5. Whoops, not percentages. I am not seeing volunteer yet. This one we can do in our head. The numbers worked out so nice.
I can do that one if you want.
Sure.
There's 4 equal sides, so it's going to be 80 divided by 4. Which is going to be 20. And then it's 20 times 20 for the area.
So 2 times 2 is 4, 2 zeros on it.
Mhm.
Okay, triangle time. I don't know if the lecture notes actually used the phrase right triangle. A right triangle just means the triangle that has one side stand up straight.
One with a 45, or yeah, 45 degree angle, right?
90-degree angle.
90 degree angle, yeah. I cannot seem to wake up this morning.
That's okay. Math isn't about getting it right the first time all the time. Okay, it doesn't really matter too much which sides I label for the short ones, but the long side, right, the kind of diagonal side, is always going to be the biggest number. The fancy name for that side is the hypotenuse. You don't really care. Now we want to know which one that is, because that's the one we don't care about. We want that the area of a triangle is base times height divided by 2. So we want a base and a height. The way I've drawn it, there kind of is a right way to label this. One of these is longer than the others. So let's take the short one and put it on what I've drawn to be shorter. And the longer of the two that's left over and put them on the longer. But it doesn't matter if I flipped these. I'm still just going to multiply them and then divide by 2. Does that make sense?
Is it 270?
I don't know. Let's see. So 15 times 36 divided by
That's
2.
what I got too.
Yeah. So again, 2 parts. Part 1 was just discard the biggest number. Whichever the biggest number is, that's the long side. Who cares?
Just for a quick clarification, when we have to write these out, when you want to see them, you did say it was totally fine just to do the little 2 symbol like next to it, like 270 centimeters and squared over that.
Yeah, we talked about that a little bit last class.
That's what I thought. Yeah, I was just double
So
checking.
if we had 276, we could write out square centimeters. We could write it out with the abbreviation I like to do. We could also write it out as 276 square centimeters this way. Some people don't like the extra exponents. It tempts them to multiply this number by itself, which is not what's happening. Right? Nothing in this picture is a square, and nothing has a side of, whoops, I put 76, but anyway, you know what I meant. So just so that nobody is tempted to multiply 270 by itself, then I don't use that style, but there's nothing wrong with it. It is easy to write. You will see it all the time in other sources.
I just wrote it out of habit, and so I just wanted to make sure when I turn in like the
Yeah.
homework, get to see the non-calculator and all that. That was cool.
Yeah, it's another thing like the difference between these, where just because I am lecturing, for me, there is a better way. For you, there isn't.
So that question was to find the area and the perimeter. So we've only done the area, correct?
Yeah, we've only done the area. How do we find the perimeter?
Add up all the sides.
Yeah. Okay, I need to label my 90. What unit will I use? What flavor of unit?
Oh.
Is it centimeters?
It is. So imagine that this triangle had hinges on the corners, and you could take the post out of one of the hinges and unfold the other two. You could make just one long line out of this triangle, right? It's just a straight thing once you unfolded the pieces. So it's just plain centimeters. It's a length an ant is walking. There's nothing about it that's different. Whereas the area is genuinely different. I am taking little squares and I'm trying to paint this with squares, and sometimes there's like half of one here that I'll put there and so on. So they're not going to be unbroken squares, but to find the area, I am going to try and put down little squares as much as I can. Okay, anyone want to be the person who does a second copy of number 6 on the board?
I can try.
Okay, let me grab one for you.
Can I just say it though? Because I don't want to turn my video on.
Can you just say it, I suppose?
I don't even know if I know how to turn my video on, is the problem.
Okay, my pen is yours to command.
Okay, so now I have a minute to do it, right?
Yeah.
Okay. I'm sorry, I'm trying to find my pencil. 1 second.
Okay. You have the 16, 30, and 34. If not, holler when you get your pencil.
Yeah,
I'm going
okay.
to do just a heads up announcement while you're doing your draft. So when we finished with shape-shifting, I put a shape-shifting midterm in the lecture notes page. That way, if you wanted this check mark for getting 70% on a midterm, you had one that I had the answers to. Because normally, if you just generate a random practice midterm, I don't know how to grade it, and it takes me forever because I have to solve all the problems. So I will do the same thing. After class today, I'm going to make another line down here after our lecture notes that will have a mad science midterm. And if you want the check mark for achievements for doing well on a midterm, and you'd rather do mad science than shapeshifting, then there you go. So look for that after class. Also, if you wanted the why our multiplication algorithm works, that's this line here with the board and the video.
You get extra points for doing both midterms?
No, but it's good practice. You get extra points for, let me, scheduling when you take practice tests. So if you can schedule when you will take 5 practice tests and tell me quick in an email or take a picture of your calendar or whatever, then that's one thing. That's part of time management. But for actually taking a test, then you only get one. Otherwise, no one would want to do the no calculator test. So. Venn diagrams. Okay. Back to here.
You know what's amazing is my toddler hasn't made any noise the whole time I've been in class, and now I go to talk and she's screaming. I don't think you can hear her because she's at the other end of the house. But
You can't hear her.
I do have my thing ready. I'm gonna say.
Okay, tell me what to rate.
So I did 16 times 30 divided by 2, and that was for the area. And then I got 240 centimeters. No, it's something squared. I messed up the unit, but it's 240.
Is square centimeters. Good catch. Okay. And
So I did 16 plus 30 plus 34, and I got 80 centimeters.
okay. Oh, thank you. Okay, so that's the ones for polygons. We also have circles. So let's look at number 7. So this one is trying to be tricky again because your instructor is a mean and terrible person. Your first one has a radius, so that's from the middle to the edge, of 26 inches. And the second one has a diameter, so that's from edge to edge, of 46 inches. When I want to do area of a circle, do I want radius or diameter? Who remembers or looks up that formula?
Is it radius?
It is radius. So this is kind of a bad picture. I don't want a diameter. So I'm going to redraw this one so that it's only going halfway across. What number is going to go here?
Be 23.
23.
23, because it's half of all the way across. Everyone happy with that? Okay, so we can tell right away this one is going to be bigger because its radius is 26 and the other one's radius is 23. But it says by how much, so I actually have to do the math. So area of a circle is pi times radius times radius. If you like the squared, you could do radius squared. On this side, area of a circle is pi times radius times radius.
Got whoa.
So before you shout out the answer, the best thing to do for a good habit is use the pi key on your calculator, which on mine I have to do a brown second function button and then 3. Yours might well be different, but if you use the pi key, then you get lots and lots of pi digits, more than displays on the screen, and you're not rounding in the middle at all. In Math 20, it doesn't really matter. If you want to use 3.14 or 3.14159 or whatever you've memorized for pi, you can. But the best habit is to use the calculator button so there's no rounding at this point in the problem. The issue with this is your answer in the back of the book doesn't always have the good habit. If whoever was doing the answer key decided that pi was 3.14, or even worse, 22/7, which some people use, then the answer key in the back of the book will have a less accurate answer because they're rounding in the middle of the problem. So use the pi key, and if you're close to what the answer key says, then be happy. It's probably that you get it right.
Yeah, it's kind of funny. That's exactly what I did, was just hit 3.14. Like, well,
Yeah, no one in Math 20 is going to complain if you just use 3.14, but kind of the good habit to build is not to round in the middle.
yeah, I got the pi key on my calculator, so I just switched it up real quick.
And I'm going to round to the nearest square inch because after all, these are pizzas. How accurately are we actually measuring them? They are not perfect circles anyway. Okay, we're not actually done though. It's asking how much bigger is one than the other, so I need to subtract. Yeah. 462. Everyone happy with number 7?
Yeah, yeah. Let's do one more maybe.
Yeah, do one more, please.
More number 7. Somebody want to do the one on the board, either showing us your work or telling me what to write? Okay, then I'll just start. I'm going to try it without the pictures. Tell me if this makes it harder or just nicer. So area of a circle is pi times r times r. This one we just did. I can steal my number. Is it 1662? So I would start working, and if I hadn't noticed before, I would say, uh-oh, I don't have a radius. I only have a diameter of 38 inches.
So it'd be half of that.
So it would be half of that. So half of 30 is 15, half of 8 is 4, so 19 inches. Oh, okay. So how much bigger was one than the other? Five 28 square. Again, geometry is a great example of personal styles matter. Some people would really like this, where there's lots of pictures of shapes and things. Other people like this, where it's just sort of formula staring at you. Whatever makes your brain happy. Okay, questions about any of that? Let's actually look at, oh, there we go. What a mad science midterm will look like. So if you wanted to try one of these over the weekends, then we're different ways to put numbers together. So fraction division, least common multiple, adding up fractions, decimals to mix numbers, terms and order of operations, percent of something.
Is the midterm going to be timed?
Nope, nothing is timed this term.
How many midterms are there?
And there's 3, one for each of the sections, shapeshifting, mad science, and justice.
Okay.
There's only one achievement for it. So when you go to the achievements of being a mather, then earn 70% or more on a midterm test. So that there's only one, do it once and that's great. The rest is for your benefit.
So we technically only have to turn in one midterm.
You don't even have to turn in one. It's just a good star because you should be doing practice tests
okay.
anyway. So for most people, it's like a free star. The thing that
If
students
you
can
did
do
more
wrong,
than one, would you count the highest score?
if you do more than one, well, once you get more than 70, then that's it.
Oh, okay. Yeah, I wasn't sure if there was one higher than that. So
Yeah. So the thing that can happen wrong is instead of going to the ones they give you that I have the answer key for, and there'll be one for mad science at the end of the day today here, then don't do a random one and then send me that because I won't know the answers because it's random. So then that takes me forever to actually work out all of the problems and things like that. So for the sake of my grading sanity, only do the sample ones if you're looking for that achievement. But do lots of them yourself. That's why there's random midterms, so there's no surprises. What else was there? Increase and decrease, the simple interest, some unit analysis, and the stuff we just did. So having seen the list of all of it, are there any of these that people want me to do problems about?
How about number 4?
Number 4, okay. Oops, that's not what I want. I don't want highlight, I want box. Here we go. Okay, I have a quarter and 1/6 and 5/12. And I'm leaving space after each fraction because I'm going to write a times something here. So some of these, you can just look at it and know what your common denominator will be. Others, you might want to use the process where you make mini factor trees. So what should we do this time?
Oh, I see it now. Okay, so the 1/4 you do times 3
Mm-hmm.
on top and bottom. So
And just in case someone else isn't as quick as you noticing it, how did she know it's a 3?
because 12 is the one that you're wanting to get to.
Right.
And then the 1/6 is times 2, so it'd be 2 12s. And then, so it'd be 10 12s.
That's a 3 though. So 3/12.
Or yeah, 3/12. So it'd be 1/4. Two 12s. So 10. So it'd be 5/6, right?
6, correct.
Okay. Thank you.
I think it was number 6 on there.
Sure. So we're back to over here. This one.
Yeah, number 6.
So my first step for number 6 is to rewrite it because I want to make space where the terms are. So 3 times 4, and I'll put a little space even within the parentheses to show that this is a term and this is a term within its own thing. Here's a plus outside parentheses, so I'll put space around it. Here's a minus outside parentheses, I'll put some space around it. There's a plus outside parentheses, I'll put some space around it. So if I was highlighting terms, I have one term here, one term there, one term there, and one term there. And that means that these pluses and minuses are just going to walk down the page. Because each term is a totally separate thing. So starting on the left, not that I have to, but why not? So 10 times 4 is going to be 40, plus 4 more is 44. And then 3 times 44, well, 3 40s is 120, so 132. 5, that's just a 5. 3, that's just a 3. And here we have 81 divided by 3 times 3 is 9, times another 3 is 27. And 2 times 2 is 4, times 2 again is 8, times 2 again is 16. 81 divided by 27 is 3. So I need another row. Three 16s would be 48. And all of that together is 132 and 48. The 2 and the 8 will go together nicely. So I'll get 180. And then add 5 and take away 3. So I got 182. Did I do all my mental math right?
And how did we determine that the 5 and the 3 were terms of their own and the 80?
Because there's a plus or minus that's outside parentheses. So anytime there's a plus or minus outside parentheses, it separates the terms.
Division does not then? Is that what it is? I'm like a little confused still.
Yeah, I forgot this part.
Yeah, I did too. That's I'm totally blanking on this.
Okay, let me do another one then. With smaller exponents. I don't want the exponents to get in the way. So what Terms was saying is that when I'm doing PEMDAS, the addition and subtraction happens at the end. So I can kind of just ignore them until the end. Well, I'm going to rewrite this thing. Actually, before I rewrite it, I'll look at this thing. Let me make it bigger this time. And wherever I see a positive or negative sign outside of parentheses, then that's where terms will break. where it breaks up into terms. Breaks, not beaks.
And so, yeah, you do everything else with the exception of the adding of subtraction till the end, right? That's what you're trying to get down to?
It's trying to say that these parts here are separate parts. They don't depend on each other.
Okay.
Could you repeat that? The phrasing just isn't clicking for me by what you mean by they don't need each other.
You got in quiet mode again, Caitlin.
Could you just could you try and repeat that again? I don't know. The phrasing just didn't click for me by what
Sure.
you mean by how they don't need each other.
So when I am doing my PEMDAS, then the addition and subtraction happen last. And everything else happens before those. So what I'm going to do is look at my long, complicated thing and say, here's the addition and subtraction outside of parentheses, because otherwise they'd be part of the P. And that will break up my problem into 4 pieces. And each of those 4 pieces will do stuff with P, E, M, and D on their own. And they don't come together until we get to the A and S step.
Would another way to say that be that you can work them out independently?
Yes.
Okay, then I understand.
So what we're doing then is saying that these are all independent. I could, if I wanted, start with the 81 divided by 9 times 2 times 2 times 2 is 8. So 81 divided by 9 is 9. 9 times 8 is 72. I can do this part first because that's all just PEMD. And here I have 5 times whatever 32 times 6 is. So 192. And 10 is just its own thing. It's not having operations yet. Then when I'm done, 990 plus 10, so 1,000, minus 6 plus 72, so that's going to be 1,000, and then 72 minus 6 would be 66, so draw. That makes sense?
Yeah, that made a lot
Yes.
more sense.
Thank you for doing that.
No problem.
Yeah, that helped quite a bit. I was able to follow through with that one and actually got it before, so nice.
And I should rewrite the code for the JavaScript so that we don't get numbers over here that are too big for mental math.
I have a question about the 2 to the power of 3.
Mm-hmm.
So you got 8. So 2 times 2 is 4, and then what is it? 4 times 4, or is it 2 times 4? Like, I guess I got confused because when I was doing it on my paper, I put it as a 6, not an 8.
So 2 times 2 times 2. That's just too much writing. So all the exponent isn't really math. It's just an abbreviation. It's like DR instead of doctor.
How many times the 2 is there?
So 2
That
times
makes
2 times 2 is what 2. So these two make a 4. And then 4 times 2 is 8.
Okay.
So on the other one, we had this. So that would be 81 divided by 3 times 3 times 3 times 2 times 2 times 2 times 2. Now what I'm just writing is wrong because we actually need parentheses here. Otherwise we're going to divide by 3 and start multiplying instead of dividing by the whole thing. But that's a minor point. What I'm thinking in my head is 3 times 3 is 9, times another 3 is 27. And here 2 times 2 is 4. And this 2 times 2 is 4, and 4 times 4 is 16. Or I can think about it, 2 times 2 is 4, double it again, 8, double it again, 16.
Okay, and so back at the problem again. So when we do our terms, like at the beginning, you have like 5 times and then the parentheses.
Mm-hmm.
But within the parentheses, we kind of break it down into terms also too, right? Like is
Right.
by itself, so we have to do 32 times 6. So we're still breaking it down by terms within the parentheses, step by step.
Yes, whenever you see parentheses, the whole game starts over. If I wanted to confuse you, I could have said, look, here is a plus, so that's going to break things up. And then we have these 2 bits here that are independent, so let's work on them separately and then put them together.
Yeah, because when I did it on my paper, I didn't do that, and I got a different answer, so I had to go back and look why. And that's why, because I just multiplied across, and I didn't stop at the plus and make that its own term. Again, I missed that, so now I caught it. I had to say it out loud. That's why I'm communicating, because if I were in a classroom, I'd be raising my hand, making you stop and start all over again. So this is the best I can do, I guess.
Okay.
Yeah. All right. Thanks.
Yeah, that is something that everyone does at first. Right? A big disadvantage of distance learning is you're not arriving at class 5 or 10 minutes early and seeing each other's work and talking together as you start the homework and thing. But as much as we are taught that math is mental, then there's something very physical even about just going through this on paper with your pencil on a piece of paper and so on. And just like everyone who rides a bicycle falls off the same way, everyone who tries this does the same thing with parentheses once or twice before they stop. So, okay, let's look at your turn-in problems. Since it's about time. No, actually we have more time. Do we need to do one more of these as review of percents or anything?
I would appreciate that.
Which one?
That number 9.
9, okay.
There was another one too, the one that's like a small business borrows a certain amount.
Okay. So we have 2 different things. One of them is 78% of 337, and the other is 70% of 361. How do you find the percent of a number?
You multiply times the number, so it'd be 337 times 0.78.
Yeah. The number stays a plain number. Of becomes multiply. And 78%, since we're going to put it in a calculator, we'll want to riplop it. Left out of percent. And of course, we'll do the same thing on the other side. Okay, now I don't know what that is in my head, but 0.78. Bigger.
Meaning that the 78% discount is bringing the value down to 262.
You could phrase it that way, yes. I'm not sure what the story problem is. I don't know if it's a discount or not, but yes, you can think of it as a discount.
Okay.
The old price was this, the new price is this. The way this problem always works, we have a bigger percentage of a smaller number, or we say the percentage for the second time isn't quite as big, but the number starts higher. And sometimes this side is bigger and sometimes that side is bigger.
And we don't move the decimal.
And you don't move the decimal. Nope. Hey, this is whatever, your computer monitor, fancy TV, something started at $337. It was on sale, only 78% was what you had to pay. So you pay $262.86 or so on. There's no ripple up at the end. It's not asking for a percent. If it helps you, imagine there's a label. Maybe I don't know, a farm bought 337 pounds of compost. There's only 78% left at the end of the planting season, so there's 262 pounds remaining or so on. If I had a story problem, I could know how to round this if I knew what practical thing I was measuring. But I don't, so I'm just going to write it. And I don't really care how many decimal places it has, because all I'm doing is picking the bigger one. Ready for the next one?
Yes.
Okay, so simple interest is designed for a year. So I start with just this amount at that percent. It's exactly like the previous problem. But I'm not done now. If the loan was a year, that would be the amount of interest. But the loan isn't. The loan is not a year, it's only 124 days. So, ancient history, some banker who was inventing this had to make a choice. Should they say, well, you paid your loan early, tough noogies, you still owe me $771.46. They could have said that, right? They were the person making the loan. but they realized all their competitors would make a different decision. So instead, we get to prorate the loan. If you pay it off early, you don't have to pay all the interest. So how much of a year went by? A fraction, 124 days out of 365 days.
I guess
Everyone
what-
okay with my fraction?
I guess what was confusing me was I didn't know how you were supposed to assume that it was a year. Is it because of the word annual?
It's just how simple interest works. That's how it's defined. The word annual is there as a reminder because I am polite, but you could leave out that word and it would be exactly the same.
So that's basically just a rule.
It is just a rule. It is how simple interest works. Yeah.
$22.8 or 0.08. Oh, 20.
I'm getting 09 because of
So
5.
I did mine. Can I show you how I did mine?
Sure.
So let's see.
I'm going to stop my share
Oh,
and highlight your screen. Keep holding it up.
can you see it?
Mhm.
That's what I did.
Yes.
Yeah?
Good segue.
Okay. That's not what you did.
That's not what I did. Okay, let me. So if you do it the way I do a lot, then you'll say, well, I do like how it looks like number 9. We're finding a percent of a number. But this is a lot of writing for just multiplying 3 things together. So we have that simple interest formula. And we can do the same problem with a lot less writing. Whoops, why didn't I copy that? It went there instead. Okay. So we can just say the first thing we're going to do is take the principal and then we're going to multiply it by the interest rate. And now the tricky part, what is the years? That's going to be the 124 days out of the 365 days. And whatever we had, 262.09. So that formula, if you want to memorize a formula, you can. All it is saying is that first we multiply together the interest rate and the principal. And then we adjust for how many days or months or years actually happened. And if you like the formula like Chrissy does, then yes, it is quicker to do it that way.
So, the way that this, okay, so the people that actually sorry, I think that putting it back into the problem is going to make more sense for me. So if the business, the amount of money the business is actually paying is $262 after 124 days.
Yep, they will owe the bank or the loan company or whatever that much money. And they have to pay back their loan.
I was gonna say, yeah, on top of the 4,000 whatever, right?
Right.
Okay. All right. I was thinking that like at first, I don't know. I was thinking of months and confusing myself.
Yeah, just like a lot of Math 20, you can make things too hard. We don't see simple interest rates very much in real life. They happen in, I'm going to make a note to send you that article. I did find it. We see them in payday loans. We see them in government bonds, but almost all the interest people deal with is compound interest. So saving compound interest for Math 25 makes your test a little earlier and easier in Math 20, but it does mean it's a little awkward if you keep wanting to see compound interest and there isn't any.
Right. Okay. It just made more sense for me to understand what was the amount getting paid back, if that makes sense. I don't know.
Okay, let's be done with this for now, and let's actually do a preview of what's coming up. Some people I know will want to rush ahead because weekends are better for them. And if you wanted to try and start homework, a lot of this justice topic, even though we haven't talked about it, is stuff you already know. And you can start ahead on homeworks and things. And if not, that's fine. You don't have to rush and do things before we actually get to them in class. But here's what we'll start doing next week. The equal signs we've seen in class so far were just like this. They were only an excuse to say we're going to do some things and smash them together. It was really just putting numbers together. The fact it was an equation just meant put your answer here. So we're changing that now. We're going to say we have some equation going on and we need to use the rules about equations themselves to get to an answer. So the basic tool is do the same thing to both sides of an equation. You've probably seen that before with problems like y minus 3 is 47. So what will we do? We'll follow the same order. First we'll do fractions, then we'll do percentages, and then we'll do measurement. With fractions, I'm going to start by making the people that love pictures happy and the people that hate pictures angry at me, as always. You've seen this before. And we'll talk about balance scales and doing the same thing to both sides of the equation. And we'll talk about how to write it nicely. And then we'll do some of these solving equations, which probably look familiar to you. Not necessarily, but most Math 20 students arrive at Math 20 having seen this kind of thing before. And I can give them to you in ways that are really easy, what I'm calling one-step problems. And I can give them to you in ways that are slightly harder, which I'm calling two-step problems. So we'll talk about the difference of those and when you need the second step and why. And that's all for that kind of thinking of balance scales stuff. Then for many students, their favorite part of the whole term is proportions and cross multiplying. There are so many Math 20 students every term, and their favorite thing to do is cross multiplying. And one big advantage of saving cross multiplying for so late in the term is that you can't do it when you weren't supposed to and all these other times. Because once people start cross multiplying, some people just try to use it all the time, even when it's the wrong tool, and then they get things wrong. So I am purposefully arranging the term so you couldn't cross multiply too early and get problems wrong that way. So cross multiplying people like, and we'll talk about why it works, because again, a big theme of this class is even the stuff you've been taught before, you probably were not taught why it works, and you deserve to know that. And we'll do lots of cross multiplying. Unfortunately, with websites, I have to make my fractions diagonal things instead of writing them nicely with one number straight on top of the other. And that makes it much harder to see the X-shaped stuff going with cross multiplying. So I will always write them out sort of nicely with one number directly on top of the other when I write them on the board, and you should also, but that's just not how typing works on web pages. Once we do some cross multiplying, then we do it with letters. So here's one with a Y instead of just checking if it's true or not. And we'll throw decimals in because it looks scary, but it's not. And then we'll be done with that. Finally, we have word problems, and everyone loves word problems, so we'll do some word problems with this, right? And this page, this slide here you're looking at will become your favorite thing when we get to it, because this is the how to actually understand what's happening with the word problems. We have a little comment about scale factors, because some of you will have jobs or careers where the phrase scale factor is used all the time. So let's talk about what a scale factor is. It's not anything new, it's just what we were doing, but we want to use the word. So that's all of fractions. Then we go to percents. So far we've done a percent of something. What is 17% of a number? What is 78% of a number? And we also did the percent of a change. If you go down and lose 11 pounds, 11 is what percent of 175? So those are two common good ways to think about percents, but there's a more general way to think about percent where you always translate percents, and of becomes multiply, numbers stay the same, is will become equal. So we'll call these things percent sentences. They have is, of, what, and percent. What is 35% of 60? 12 is what percent of 5? 5 is 2% of what? And we'll finally just be working with percents in general. And you'll see that we'll use the same things we did before, but it's actually easier. It's kind of more freeing to not have to make up categories. Is this one a decrease? Should I use the decrease trick? Is this one a percent of a number? Should I use the percent of a number trick? Instead of trying to remember which type of problem we're looking at, it will just all work the same. So this will be refreshing once you get good at it. There's two ways to do it. You can translate, as I just said, or you could use a proportion. So where did the proportion go? There's no good picture, but if you like cross multiplying, more cross multiplying, cross multiply so your heart is happy. And then we have word problems and the trick for the cross multiplying with the word problems, and then we'll be done with percents. Measurements, we have Fahrenheit and Celsius, and there's so many formulas here, but that's just because some of you will go into careers where you might see these not as standard ones. Almost everyone just likes this one and this one because it has the decimals and no fractions. So that's the ones you'll write in your notes and be happy and ignore the others. And then we'll get to the fun part. The class ends with these area puzzles that I mentioned before, where we take bites out of shapes or glue shapes together and try and find the geometry answers there. Some of them look pretty, some of them aren't. I give you some links to some really hard puzzles if you like this kind of thing. And the very last thing, just for those people going into Math 60, is we talk a tiny bit about negative numbers and variables, so that when you start seeing more of those in algebra classes, then it's okay. So this isn't as long as Mad Science. So we are ending week 6, so weeks 7 and 8, we'll do this, and then we'll just have lots of review. I don't think it will take us more than 4 classes to finish the justice topic. So you'll start, just like so far, you've been starting classes by bringing me homework questions, sometimes from the random homework, but usually from the turn-in homework. Then at the end of the term, you'll all be bringing me questions from practice tests, because you'll be doing practice tests like crazy. Okay, questions about that overview?
No, I think it was pretty straightforward.
Okay, so for most people, the hardest part is done. You have some experience with equations. Cross multiplying is something you've been taught to do and like. and percentages won't be so hard, and the area puzzles are kind of annoying and kind of fun based on if you're in a mood for puzzles that day.
I have a question about turning in like written problems. Like I'm just confused when it says like turn in a sheet with 16 written characteristics or something. Like
Yeah,
what
a
is
couple
that?
times you have to write things neatly. So just take the homework that you've probably done anyway and take a
Okay.
picture of it with your phone and email that to me.
Okay, so that's all that is.
Yep.
Okay. Cool.
I'm assuming that other people don't have the fancy stylus things to write with on the screen, and your handwriting would be terrible if you're not used to that anyway. So yep, just take a picture.
All right.
As long as we're on that topic, what will happen at the very, very end of the term, and what that is will be different because some people will decide they're done earlier or later than other people. There's not really a day of a final exam this term. So we'll go down to the end of term tests, and some people will want to do the no calculator test to get that star. Some people will just go right away to the overall tests. And when you're ready, you'll say, okay, I am ready to try and pass my final. And I will take one of these and print out a copy for me with the answers and print out a copy for you without the answers. And then I will send you the PDF of your copy without the answers. And then you will do the work and send me pictures of all your scratch papers, and I will grade it and grade how that you're showing your steps nicely and things like that also. And then we will have a debriefing either on Zoom or by phone. And the more you show your work, then the less I will ask you about things, because you've already shown me what you were thinking. But for some of these, they're just kind of easy rip-lop things, and you don't show a lot of work. So I will say, so how did you know to do this here? Or how did you know to do that there? And then you'll tell me.
So this is a practice final you're showing us right now.
This is right now as a practice final.
And you want us to do the whole practice final and send you it?
Not yet, but this is what we will do at the very end of the
Well,
term.
at some point, yeah.
Yeah.
Okay.
So, and some of you will wait till what we're officially calling finals week in spring term 2020 and kind of study and study and study and take it later. And others people will say that, okay, I'm just going to try it Monday because why not? And if you don't do as well as you want the first time, then we'll do it again. Last term, we did finals the same way because everything closed down before finals week. And some people took 2 or 3 tries. If you want an A, then you'll need to get 66% on the final. And if you want to be 60 and a C, 50. If you do better than that, then you get more stars, right? If you get 70 or 85. Any other questions? Good questions. Okay, well, have a good weekend. Maybe see you Friday for the study session. Thank you so much for all your contributions to the discussion today.
Thank you.
Thank you.
Thanks, David.
Have a good day, everyone.
You too.